Well, hello and welcome YouTube to Mr. Robinson's Q&A Power Hour. This is actually going to be kind of a quick one, or at least I hope it will be. Two questions for you guys that were asked to me on sequences and series of arithmetic geometric variety here. Normally I don't look at the questions beforehand, but because there were only two questions, I decided let's read it and see what we got. So let's take a look at what these two questions are here. And it's kind of important to actually look at them beforehand because the first one, student did a no-no. They gave me an example of something, and more importantly, I don't see what the example is, so good thing I looked at it beforehand. All right, what do you do in sigma notation when the equation is not an explicit formula? For example, question 2C on module 12, review A. Remember, when I do these, I generally don't look for where that is. Thankfully, I did get to look it up. So I'm going to pop it up right here, or I'm going to write it down. I have it popped up on a window. So I'm going to write this down. This is, whoops, I guess I got to move this over a second. So I'll talk a little bit, I'm going to dance around the question a little bit because it's a bit of a loaded question in a way. I'm going to talk a little bit about sigma notation. I'll talk a little bit about explicit rules and all that within. So here's the question in play. They're asking us to find this sum right here. Now, I do want to write another one alongside it. This is question 2C that they were talking about. There was a question 2A that looks like this right here. Let's look at the difference between these two and talk about sigma notation and all that. Okay, so the question, going back to it, was, once again, what do you do in sigma notation when the equation is not an explicit formula? Well, the question's kind of a mistaken question because you see this is explicit formula right here. When you look at sigma notation itself, what sigma notation does is it substitutes values for n, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 into right here. And then you add up the results of all those. Plug in 1 for n, plus plug in 2 for n. What is that? Plus plug in 3 for n, etc. All those. Same here, same right here from 1 to 13. Plug in 1 for n into here, plus plug in 2 to n, all the way to 13. So that's what sigma notation is and does as a machine here. Now these two things, these are both explicit rules. Now you look at this one and you say, oh yeah, this is your a sub 1 plus d times n minus 1. That's the explicit rule we use for an arithmetic sequence. And I get it. This particular explicit rule clearly establishes that this is the first term. Because check this out. What happens when you plug in 1 to n? Negative 4 times 1 minus 1. Negative 4 times 0 is 0. And you're just left with 6. Makes sense. What happens when you plug in 1 for n here? Do you get 6? Do you get negative 3? No. 6 times 1 minus 3 is 3. Neither of these are the first term, so this must not be an explicit rule, right? Wrong. Explicit rule doesn't mean the rule has to look like this. Explicit rule means you plug in the number for your position, you get a value out. If I want to figure out the value of the 7th term is in this right here, I substitute 7 for n. 6 times 7 minus 3 is 39. That is the 7th term of this rule. That's not the sum part, just that's 7th term of this rule. I plug in 7 into here, guys. I get the 7th term of this. Negative 4 times 6 is negative 24. 6 minus 24 is negative 18. Boom, that gets negative 18. Explicit rule means you plug in the value for n, you get the value. You plug in the term position to n, and you get a value out. That's what explicit formula mean, or that's what explicit rule means. Period. This is an explicit rule. What if I took this particular explicit rule and I distributed negative 4 into here? Then it becomes 6 minus 4n plus 4. And what if I combined the 6 plus 4 and I get 10? I get negative 4n plus 10. What if I had this written right here in place of there? Will the terms change when I substitute 1, 2, 3, 4, etc. all the way up to 13? No. No, you still get the same values out. Is my 6, does my a sub 1 appear in this formula? No, it doesn't. So the explicit rule we've been doing may show a sub 1, whereas these ones don't. In fact, this one here, you might see some other rules written where this is a sub n equals d times n plus a sub 0, like that. There's no real 0th term in sequences. It starts from the first term. It's a theoretical 0th term. 10 would have been the term before 6, which would have then had 2, and etc. It would have been the term. It's not really there. That's another way you can see these rules. You'll see some old videos of mine where I use that. Depends on how the teachers teach. I teach it with the a sub 1 because I asked my math department, which way are we going to use? And they said a sub 1. So I said, hey. And I don't want to bog you down with multiple formulas. You're like, wait, what's this one? So we just do what we do. But I'm introducing that to you. Bottom line is, in sigma notation, they always use explicit rules because you need to get the values out of these terms when you plug in 1 for n and 2 for n, etc. You need all those in here. This is an explicit rule. Just neither of these things happen to represent your first term. If you want to get your first term, you substitute 1 for n. So I don't know if that fully answers the question. It should. It better. I don't know if that fully addresses what you're asking, though. It's not the explicit rule we've been working. So what was the question itself? What do you do in that thing? If you want to find a sub 1, you want to find your first term, substitute 1 for n. Find the last term, 13th term, whatever it was, substitute that number in for n. You get them. It is an explicit formula. It's just not the one that you're used to that shows a sub 1. Okay, so there's that first question there. Pretty long-winded. Second question and last one, how do you treat the n minus 1 in the recursive formulas? So the recursive formula itself, let's say we were looking at, let me kind of come up with an example here, 2, 5, 8, 11, like this, etc. A recursive rule for an arithmetic sequence is, it states this. You want to find the value of some term. Unlike explicit rules where you plug in a value for n and you automatically can compute your value, here you'd have to know what the previous value is, this a sub n minus 1 plus d. Here's how rules work. And you got to mention what a sub 1 equals as well. So in this particular instance right here, what we can say is a sub 1 is 2, the value of the first term is 2, and then we are adding 3 each time from one rule to the next. These rules are a little bit weirder to look at, more so to use mathematically, and they're asking us how to use it, and I'm going to tell you. But here's exactly what the rule is telling you. Start from 2 and add 3 to get the next term. Let me show you. Notice how a sub 1 is 2 right now? Let's say we wanted to find a sub 2. We already know that it's 5, but let's say that we wanted to find it for ourselves. We didn't know that it was that yet. Notice how this says a sub n. Well, what if n was 2? Okay, now let's do a sub n minus 1 over here. What's a sub 2 minus 1? That's a sub 1 plus 3. If you want to find a sub 2, you got to do a sub 1 plus 3. We know what a sub 1 is. It's 2. A sub 1 is 2. 2 can take a sub 1's place. So a sub 2 equals 2 plus 3. A sub 2 is 5. Notice how that 5 comes up there? That's what that little n minus 1 is doing. It says value of the previous term. To find the value of the next term, take the value of the previous term and add 3. Let's do a sub 3. A sub 3, a sub n, equals a sub n minus 1. 3 minus 1 is 2. A sub 2 plus 3. A sub 2, we found that out. That's 5. So what are we going to do? Substitute it in for a sub 2. A sub 3 is 5 plus 3. A sub 3 is 8. Let's do a sub 4. We should get 11. A sub 4 equals a sub 3 plus 3. A sub 3 we found out was 8. Let's substitute that for a sub 3. A sub 4 is 8 plus 3. A sub 4 is 11. And this continues. Now, do we need to do this work to get these values? Heck no. Heck no. You would just follow what the rule is telling you to do. If I showed this pattern to anyone second grade and above, just to be sure, anyone second grade and above, and I asked what the pattern's doing, everyone would tell me. They'd all say what? Add 3. That's what this is telling you as well. What they mean is, if you want to find the next term, you add 3 from the previous term. And that's what this is telling you right here. Find the value of the next term, take the previous term, and add 3 to it. What you also have to mention, of course, for this particular rule is, starting from 2, we add 3 over and over. That's just one example. I'm not going to do a bunch of others, but let's make up one more. Let's make up one more. This time I'm just going to give you the rule, and I'm going to say, hey, fill out the first 4 terms from it. Let's try this one. A sub n equals a sub n minus 1 times negative 7, where a sub 1 equals negative 3. These numbers might get a little big. First 4 terms. Well, the first term's negative 3. How do we get the next term? Well, you take the previous term and multiply by negative 7. So negative 3 times negative 7 is positive 21. And then you multiply that by negative 7 and you get negative something. negative 147, I believe, and multiply that by whatever, the first three terms. I'm fine with that. But that's what the recursive rule does. And that's what this is telling. This means value of that next term you're looking for, value of nth term, of term. You want to find the value of a term? Take the value of the previous term and then do this thing. But I show you mathematically how it kind of works in that slow process. We don't tend to do that. I might have a video where I do that, but we don't tend to. All right, guys, those were the only two questions that were asked. Took about 10 minutes there. I know that I wanted to spread it out a little bit because I could. This is Mr. Robinson. Thank you so much for watching. Let me know if you have any more questions for me. You can submit them down below. I'll have to answer through text, though. That's our power hour for today, power 10 minutes. Take care. I will see you in the next one.